This is 5.4, solving special systems of linear equations. So a system of linear equations can have one solution. That's where we have two different lines and they intersect at one point. So their intersection here is the solution, so this one has one solution. We know that because the lines intersect and they have different slopes. A linear equation can have no solution. So here we have two parallel lines and they will never intersect. So if they never intersect, they never have a solution. They never have any points in common. So for no solutions, they have the same slope, that means they are parallel, and they have different y-intercepts. And our third option would be for lines that have infinitely many solutions. So that means that all their points are the same. So they are the same line, they have the same slope, and the same y-intercept. They're exactly the same. So solving a system with no solution, if I have y equals 2x plus 1 and y equals 2x minus 3. The first way is to graph it. So I have my slope and intercepts. So I can graph these two, and I can look and see that they have the same slope, and so I know that they are parallel. I can see that here because they never intersect and they don't get closer. So they have no solution. Method 2 would be to solve by inspection. So that means I have to think about it a little bit. So I can rewrite them, and if I put them in standard form, x plus y equals a number, I can see that negative 2x plus y equals 1 and negative 2x plus y equals negative 3. But negative 2x plus y cannot equal 1 and negative 3 at the same time, so there is no intersection. For it to equal the same number, that means that it would have something in common. It would have a point of intersection. So we can see that from this reason, there is no solution. Or I can think about it and explain. So I can say they have the same slope, which means they are parallel, which means they have no intersection, and therefore no solution. Now, for solving a system with infinitely many solutions, if I have y equals 3x plus 2 and negative x plus 2y equals 4. First, method 1, solve it by graphing. So here, if I graph them, we can see that they are the exact same line. So to do that, I had to put this second equation into slope-intercept form. So that means solve for y. And I get y equals 3x plus 2. That's what my first equation was. So they are exactly the same, so they are on top of each other here. So all their points are in common, so it has infinite solutions. Another way that I could solve infinite solution problems is by elimination. So with my two equations that I had, y equals 3x plus 2 and negative 6x plus 2y equals 4, I can solve by elimination. So I'm going to multiply this top equation by 2, and I get 2y equals 6x plus 4. Remember, with elimination, I want my x's or my y's to have matching coefficients. Now if I put it in the same form, in standard form, x plus y, then I have negative 6x plus 2y equals 4 and a negative 6x plus 2y equals 4. If I subtract these two equations, I'll get 0x plus 0y equals 0. That means 0 equals 0. 0 is always equal to 0, and so all the points on the graph are the same. So from here, I can say it has infinitely many solutions. I could also solve by inspection. So I would think, and I would say, once I would get it to here, my equations look the same. So I would say they have the same slope and the same y-intercept, therefore the lines are exactly the same, and so it has infinite solutions. So look at this example, y equals 5x plus 3 and y equals 5x minus 1. These have the same slope, but different y-intercepts. That means that there is no solution because they have same slopes, different intercepts, and therefore they are parallel lines. Parallel lines have no solutions. In this example, y equals 9x plus 8 and negative 36x plus 4y equals 32. I'm going to rewrite this so that they have matching coefficients. Multiplying the top equation by 4, I can see that they are exactly the same. I have negative 36x plus 4y equals 32. They are exactly the same, infinite solutions. Here's another example. If I have y equals 1/2 x minus 3 and y equals 4x minus 3, I can see that they have different slopes. So different slopes tells me that they are going to have one solution. I also see that they have the same y-intercept. So since they have the same y-intercept, they are going to intersect at that point. You could substitute one of these into the other. You could solve by elimination, or you could graph it. But you will get your solution is 0, negative 3.